Engineer Adeniyi Olubiyi is a mechanical engineer with extensive experience and management skills. A graduate of Federal University of Technology, Akure, he is a technology-driven individual. He successfully designed Bovas lubricating plant (EPIC) with special details to plot plans, piping general arrangements, and 3D equipment models with Revit architecture, MEP, and PDMS softwares. He has consulted for Apple and PL Limited in the design of a bucket elevator, screw and chain conveyor system for the processing of soya bean, and assisted in the fabrication of a soya bean silo, fabrication of a mixing kettle for the production and packaging of soya oil. He successfully designed, developed, and supported live projects such as 2D and 3D designs and modeling of Ibara and Itaoshi major fountain roundabout for the Ogun State Ministry of Works and Housing. He is vast in the computer programming as well as he developed an expert system for the repair and maintenance of bulldozers' work equipment. He also developed a program on computer-aided approach to maintenance and planning of automotive and workshop using QU model. With his vast and refined experience, he decided to establish Poland Ventures Nigeria Limited. In 2018, Poland Ventures was established as an independent organization to provide building and architectural services to both public and private establishments. The company has placed an industrial focus for knowledge and technology development, as well as to showcase our high-quality services, rendering good value abilities with an appreciation for our nature-beautified community. He is married with 2 kids. Please, let's welcome Engineer Adeniyi to the platform. You have the platform, sir. Welcome, sir.
Good evening, everyone. Um, I am glad to be
Good
with.
evening, sir.
Yeah, thank you. I'm glad to be with the engineers this evening, and I'm very sure that we will be able to, at the end of this presentation, we'll be able to pick one or two things that will be useful towards our life projects and progress, careers, job opportunities, and the rest. Uh, and majorly today's presentation has some little level of breakdown, which I'm going to show us through the slides very soon. I will have the brief introduction into CAD designs, Autodesk Inventor, the AutoCAD, the similarities between the two and their differences, advantages of CAD, the career and job opportunities that lies in the advantages of having the knowledge of the CAD, or let me say the Autodesk and AutoCAD. Then there will be the opportunity for further questions as regards the program. I hope we can all hear me clearly. I hope we can all hear me clearly, please.
We can hear you, sir.
Okay, thank you so much. And at this stage, I would like to share my screen with you as regards the presentation, the little slides that has been prepared, so it could give us a proper guideline and the little knowledge about the knowledge. Wouldn't want to say little per se, but the knowledge about the major programs of Autodesk Inventor and Autodesk AutoCAD per se. I have the screen on. In matter of fact, I want to be sure we all have we can all see it clearly. All right, I think I may proceed at this stage. Like I said earlier, I'm here to talk about Autodesk Inventor Professional, the AutoCAD, and their importance in engineering profession. A brief introduction into CAD. CAD, as we know, is a short form of computer-aided design, and is used as it's a program that is, or let me say, it's a software that is majorly designed for that is majorly built for design engineering design purposes. CAD software is frequently used by different types of engineers and designers, and it can be used to create 2D drawings, 3D modelings, and it is majorly used to design and document products which are in view of conception or which are in view of fabrication. And with 3D CAD, you can share, you can review, you can simulate and modify designs easily. At this stage, I would want to throw a little light about the part of the simulation. In the world we are today, as technology is growing rapidly, there is the request for the limitation of human errors. And this has actually made some set of engineers and programmers come together to sit down, conceptualize a method where there wouldn't be a case of trial and error. You know, in engineering, definitely they take safety very, very important. They take it as a priority. Therefore, in order to actualize the dream to bring down human errors and other unsafe methods of production, they needed to come up with computer methods of handling engineering designs, which birth the computer-aided designs today. And I would say we we as engineers, it is becoming imperative for us to have a proper knowledge of what we want to do, how we want to do it, and which form it's going to follow. And that is where the CAD design comes in. In universities, at the stage of graduation or in the final year, most importantly, projects are given to students with different topics, and they tell them to work on it. So most people who are into fabrication, it requires a proper knowledge of design. And at that stage, computer-aided design is very important. For one thing, conceptualization of a machine, then putting it into real life before fabrication is something that is paramount with engineering design nowadays. And it is becoming a day-to-day activity for most engineers in almost all fields. In fact, not only limited to engineers, we have other fields coming up with programs that brings down, that gives them the opportunity to have a review of the projects before it is actually brought to life. That is where the simulation comes in. When you design a machine, you have the opportunity to see how it works right before fabrication. When you see how it works, that can help you to determine where there will be a proper material selection, and as well as where there would be need for other adjustments per se, depending on which machine you're handling. That's why majorly nowadays CAD design is a very important program for a basic knowledge in engineering. Let's proceed into the AutoCAD Inventor, which is a program majorly designed for mechanical engineers. The Autodesk Inventor it's a purely machine design program. As it is in the slide, it says Autodesk Inventor is a computer-aided design application for 3D mechanical design, simulation, visualization, documentation, and product simulation tools developed by Autodesk. Autodesk decided to bring up this program in order for a basic machine to be properly designed before fabrication. Nowadays, most companies that prefer having their machines simulated on the system. In fact, in civil engineering as well, before bridges are constructed, before tunnels are constructed, both on land and water, they take samples, they design these things on the system, they run it on simulation according to load impact and the rest before they can say, okay, fine, this is the right step to take, this is the right design, this is the right material to choose. So it is with mechanical engineering as well. So, like I said earlier, the Autodesk Inventor is majorly designed for mechanical engineers, people who are interested in machine designs. In Autodesk Inventor, it gives us this opportunity to design a machine in parts. When you are able to design your machine in part, conceptualize it in parts, then it gives you the opportunity to then assemble. From assembling, that is the mechanical component design. It consists of the parts drawing, the assembling, the explosion, the simulation, and the presentation. In that program, you are able to start to design your machine parts by parts. Let us pick an example, a combustion engine, probably a four plug or a three plug, depending on which one you want to design. In this combustion engine, you have the engine block, you have the piston, you have the piston ring, you have the connecting rod, you have each of these bolts tying, or let me say, connecting all of these parts together. By default, these parts are produced with different materials depending on which service it's going to render. And all of these materials would be selected, will be designed right in this program. So conveniently, it gives you an ample chance. With the slides, I will show you some samples. In actual fact, it gives you the ample chance for you to be able to design your machine even before it is fabricated. And the advantage of this is that it brings down material loss. It brings down cost of production. So in most cases in fabrication industries, an example like Coleman that produces wire, which I have been there on 2 or 3 occasions. They try as much as possible to simulate whatever machine they are going to use and see how it's going to function in a flow design, a process flow design in their own environment. So in actual fact, when you're able to design a machine, then assemble it parts by parts, then you have it at the explosion stage. The explosion stage is where you have assembled the machines into a single, you have assembled the parts, I mean, into a single machine, and you are able to split it up to show the contents, the interior contents of a machine, like I used a combustion engine for example. When you speed it up, you have this as what the illustration that I was trying to make, like that which I have on the slide. It shows the piston, the connecting rod, the crankshaft, and the rest, which by default, when a machine is assembled, you are unable to see all those parts independently. But in the design stage and the explosion stage, it allows you to see the interior of the machine you have actually designed and assembled, and through which you have the chance to simulate and see how that machine is going to function. You're going to check the stress limit. You're going to check the breaking point. You're going to, by selecting each material, you check how long that material can actually last, and how far the material can serve you. This Autodesk Inventor gives you the opportunity to have all of this designed ever before fabrication. Therefore, it brings down correction losses, it brings down material losses, and it gives you some level of safety assurance that this machine has been designed assembled, all appropriate test has been made ever before it is fabricated. So it makes it acceptable at the international standard organization level, and so the other organization that regulates the production of all the production generally at that stage. So it helps you to bring down majorly the costs and wastage at the level of fabrication and production. Back to the slide. This is an example of an electric motor. This electric motor has been designed with Autodesk Inventor, and in actual fact, here, this is what I will call the assembled stage. I would show you here an example of an explosion stage where the interiors of these electric motors will be separated. And I have this here. This is an electric motor in the modeling stage where it is separated. Being able to
Sorry,
do this at
I'm not seeing your screen. Am I the only one not seeing your screen?
Oh,
Yes, yes, it
I'm
is.
very sorry. I think I asked earlier if you could see the screen in actual fact. Let me go back a little just to show you the illustration that I was trying to make earlier. This is the assembled electric motor designed with Autodesk Inventor. This is at the assembled stage where all parts in pieces has been assembled together for simulation. This was the piston connecting rod crankshaft design that I mentioned earlier, where you have all this assembled together, and definitely at a stage where you are able to explode in the sense that you are able to separate each part into pieces to be able to identify and make sure that all of these pieces are matched together for a proper machine simulation. And the funny thing about Autodesk Inventor is that when you design a machine and afterwards you put the machines together and you are able to simulate, if there is a missing part in that machine, Autodesk Inventor will let you know that at this stage it will bring something like a program error that at this stage this machine is going to fail as a result of one thing, or probably let us use a bolt as an example. The bolt that holds the connecting rod, and or let me say that when there is no piston ring there, and you simulate, definitely there wouldn't be proper compression. So at the stage of simulation, Inventor will let you know that there is the piston ring missing in that design. Therefore, it will help you know if your machine is going to work appropriately, or if there is a clearance that will lead to probably leakage in compression, and that will affect the proper functioning of the combustion engine in actual fact. So Autodesk Inventor will let you know at the stage of design that this machine is going to perform properly or it's not going to. This is the exploded view of the electric motor earlier shown on the slide. At this stage, it allows you to be able to label appropriately and to be able to understand if these parts are properly matched together, depending on the constraints and depending on the functionality of all these parts. That is majorly the function of Autodesk Inventor. It's majorly designed for mechanical engineers who are looking to major into machine designs and simulation. I would want to shift a little bit to Autodesk AutoCAD. They have very similar. They have very similar. Okay, before I proceed further, This is a simulation and stress analysis stage in Autodesk Inventor. This is just a typical example of a car and the aerodynamics for it. If you can see, it's telling you that if the car travels at this wind speed, which is shown on the screen, then there could be a little problem with there could be a crack or a little problem with the engine block when the car overspeeds. It is very likely that at a certain speed, at a certain revolution, you might have an engine block breakage. This is showing clearly a simulation of an engine block inside a car, which at a design stage, won't be able to know how one will be able to know the functionality and the durability of that engine block. I would have been able to show you all those the simulation in video, but that would take a little time. But with time, if I could send these materials to the coordinator of this program for everyone to see. This is one of the advantages of the Autodesk Inventor. It is clearly showing to us how how this machine can work and the durability of the machine.